Question 5. A. M reacts to form R by the addition of one reagent as shown in figure 5.1. Here in figure 5.1 we have cyclohexene. With a reagent it gives a diol. So here, to convert the alkene to diol we need a strong oxidizing agent. So for this, identify the reagent and condition for this reaction, and the answer will be cold dilute acidified potassium permanganate. B. R is also made from M by two steps as shown in figure 5.2. Here the cyclohexene in step 1 is giving 1,2-dibromo cyclohexane, and in step 2 it is converting into a diol again. 1. Identify the reagents and conditions for step 1 and 2 in figure 5.2. Step 1. Here the alkene is converting into bromide. So this is an addition reaction. So for this we need bromine in dark, because in presence of sunlight the product will undergo free radical reactions. Therefore, to avoid that we need to add bromine in dark. Step 2. This dibromide is converting into a diol. For that we need aqueous sodium hydroxide with heat. 2. Name the mechanism for step 1 in figure 5.2. In step 1 we can see that 2-bromine is added to the cyclohexane and giving 1,2-dibromo cyclohexane. So it is an addition reaction. Let's take the mechanism here. In first step, this pi electron cloud is attacking the partially positive charged bromine, and then it is giving this intermediate where we have one bromine added to the cyclohexane and there is a carbocation in the structure. Now here the another bromide with negative charge will attack the positive carbocation and will give the final product 1,2-dibromo cyclohexane. So here the bromine is acting as an electrophile. So the name of the mechanism for step 1 will be electrophilic addition reaction. Part C. The infrared spectrum of R is shown in figure 5.3. So here is our figure 5.3, and table 5.1 is giving all the infrared absorption range for different functional groups containing the bond. Use the absorptions in the region above 1500 per centimeter in table 5.1 when answering the question. Add F to figure 5.3 to identify the peak that is present in an infrared spectrum of both Q and R. Identify the bond that corresponds to the absorption for F. Let's check Q and R first. So here we have Q and R. In both compounds we have a cyclohexane which is a alkane and have carbon hydrogen single bond. So here in the spectrum of R we are having two peaks, and from the table 5.1 we can see the bond carbon-hydrogen for alkane, giving absorption peak at 2850 to 2950 absorption range. So for F, from the figure 5.3, we have a peak at 2900 for F, and for this the bond is carbon-hydrogen bond, which is present in both Q and R. So the answer will be carbon-hydrogen bond. Add G to figure 5.3 to identify the peak that is not present in an infrared spectrum of Q. Identify the bond that corresponds to the absorption for G. So let's check the infrared spectrum of R again. So we know that our R is a diol with two hydroxyl group in it. And in Q we have two bromine. Here is our Q. So in Q we don't have the two hydroxyl group as R. So from the table 5.1 we can check the OH hydroxyl will give absorption peak at 3200 to 3650. In the infrared spectrum we have a peak around 3600 for G, and the bond is hydroxyl bond. So the answer will be OH or hydroxyl bond. Part D. Y is made from Q in a three-step reaction. Q is the 1,2-dibromocyclohexane. In step 1, it is reacting with potassium cyanide in ethanol in presence of heat. So with potassium cyanide in ethanol, it will undergo substitution reaction, and these two bromine will substitute by 2-cyanide functional group here and will give the product W. In step 2, we are getting 2-carboxylic functional group here. In step 3, with a reducing agent Z, we are having a diol. So the carboxylic acid group in X in converting into OH group here in presence of a reducing agent Z. So the main difference here is in this section. This 2 CO group is converting into CH2 group. 1. Draw the structure of W in the box in figure 5.4. We have already drawn the structure of W with 2-cyanide in it. In step 2, W is heated with hydrochloric acid to produce X and an inorganic product. Identify the formula of the inorganic product. So let's get back to W. Here in step 2 we are adding hydrochloric acid. So with hydrochloric acid, this cyanide bond will break and the 2 nitrogen will give ammonia, and we will also get this carboxylic acid here. This ammonia will react with the reagent HCl. So ammonia plus hydrochloric acid, it will give ammonium chloride. So the inorganic product here is ammonium chloride. In step 3, X reacts with reducing agent Z to produce Y. Complete the equation for the reaction of X with Z. Use a molecular formula to represent the organic product. Use H to represent one atom of hydrogen from Z. So here from X to Z, X to Y, we are adding a reducing agent Z here, and we are getting a diol. In this diol, we have 8 carbon atom, 1, 2, 3, 4, 5, 6, 7 and 8. And we have 16 hydrogen atoms here and 2 oxygen from this 2 hydroxyl group. So the molecular formula of Y is C8H16O2. And from X to Y, we are actually removing 2 oxygen from the carbonyl group here. And we are adding 4 hydrogen atoms in CH2. We can see that removing the 2 oxygen atom from the carbonyl group and adding 4 hydrogen from the 2 CH2 group in Y. So from these 2 oxygen and 4 hydrogen, we will have 2 moles of water. Now we just need to balance the reaction. For that we need to add 8 hydrogen and 1 X. Now identify Z. As it has already mentioned, it is an reducing agent, so we can write lithium aluminium hydride here, and that's all.